Okay, the data mining process involves several steps here, and we really have two different flavors. One's what's called experimental data mining, where you're just exploring. You might not have a goal, and you have a data set, you're crunching on the data set, and you don't know what you're going to come up with, so you're just trying out different things. Goal-driven data mining is empirical based, which means we have measurable goals, a little bit more formal in the approach here. Okay, and this table shows a lot of aspects of the data mining process. Sometimes what happens, there's a person called the domain expert. They don't know data mining, but they might be an expert. Let's say they've got a strong financial background or a strong biological background. Years ago, I was working with various folks in computational bioinformatics at the University of Texas Medical Branch in Galveston. They were physicians. They understood the biological aspect, not well versed in the data mining aspect, so we worked together and had a nice synergy. Well, let's see, when we start out, one of the first things we do is we collect the data, and data sources might be within a corporation, synthetic data, maybe you create the data in Excel, we either purchase the data or some data we found on the internet. And once we have the data, there are different aspects of the data. We want to see whether the data is numeric or non-numeric. Non-numeric might be like letter grades, A, B, C. Non-numeric might be a student's major, for example. Data, we also view it as either structured, and that would be something that's in like a database, semi-structured like XML. Unstructured could be a Word document or a web page, for example. Then there's what's called spatial, temporal, and time series. Spatial data is geographical based, and for example, we might be tracking the path of a hurricane. Temporal has time base, and time series have time base on a regular basis. And then there's what's called these measurement scales: nominal, ordinal, interval, ratio, and absolute. And I believe we talk about that here in a little bit. And once we have our data, we want to go through the process of cleaning the data, get rid of outliers, add any missing data. We might have to scale or normalize the data, and we also want to remove erroneous data. Now, once we have the data in good shape, we then proceed to pre-process the data. We might try to eliminate some of the columns, do what's called binning, sampling, or parsing, and a lot of these we'll explain later. Now, you've noticed I've got this section in red, very important. We want to ask lots of questions about the data. And week 2, the data and data mining, we'll actually talk about that. We also want to describe what type of problem. Is it a classification, regression, clustering, or an association type of problem? So we think about what questions we can ask about the data and what type of problems might the data be representing. At this point, we don't know these terms, and we'll go over that, and I think it'll become clearer. It's important, though, because as we do this, that'll impact what data mining tools we use. If we view the data as a classification problem, well, we're going to use a decision tree. If it's regression, we might use neural network genetic algorithms, for example. So we have these models. We build the models, we extract out information, and we use this information to make decisions, okay? And at some point, we go back and we calibrate, which is we try to improve the model. That's not shown there. And as we go about it, we validate the model, we verify and backtest. We test it against historical data. And the more we can test it against historical data, the more confidence we'll have in our solution that we've developed. So we start out, one of the first steps is observe reality. We ask questions, we formulate a hypothesis. So we might be looking at biological data and say, how does these DNA patterns relate to diseases? And then here's an example of maybe a hurricane in the Gulf. And we might say, is global warming a real issue? Third case, we're looking at financial data. We might say, how will the stock market behave tomorrow? So, an example of observing reality and formulating some questions. Well, one of the things is I call goals versus curiosity. Sometimes, and curiosity is something I hope you can develop in the class as we proceed. And what you might do is define relationships between variables and a dependent variable, kind of the class variable we call it. A knowledge worker might see if it, explore and see if there's anything interesting there. And we might set up goals for decision-making process. Establishing a goal helps us get focused on what we're trying to do. So some goals. Build a financial model capable of producing winning trades, find a cure for cancer, or predict with 97% accuracy the path of a hurricane. Well, those are some goals, but we might want to refine them and have empirically measurable goals. So build a financial model capable of producing winning trades is very general. Now, if I said something produces 2 winning trades and 100 losing trades, that's not very good. So we might say build a financial model that consistently makes money. Well, that's an improvement, but then we want to say something like build a financial model that produces an annual profit of 20%. Now we've got a very specific goal in mind, empirical goal, and we can look a year later whether we've attained that goal or not. Now, sometimes what happens, you might, at the end of the course, be very strong from a data mining perspective, but you might not be strong in terms of domain knowledge. Like maybe you're not a financial person that's ever traded, so you don't understand the stock market, or you don't have a physician's degree, a medical degree, so you don't understand bioinformatics. And so it's not unusual that you might seek out those people. They provide domain knowledge and insights that are very helpful and can short-circuit the process, make you speed along in terms of coming up with a solution. And those people can be quite valuable. The next phase is to collect data. And as you know, data mining requires data. Now, there are different things to think about regarding the data. How much data needs to be collected? Is it possible to have too little data, too much data? What good is the data collected? Does it provide any useful information? What type of data is it? Is it numeric or non-numeric? We want to pay attention to that because certain data mining tools only work with certain types of data setups. How good is the quality of the data? Some organizations collect data and it can be poor quality of data, and it could sabotage the whole data mining process. Back in 1998, I was collecting data for my PhD, 96, 97, collecting data for my PhD, and the organization was pretty disorganized, and the data I had was just terrible data. And I spent a year collecting the data, and the problem is that I could not use the data mine it, so I lost a year in my research because I had bad data. So sometimes a company can collect data, but you can't do much with it because it's not collected under very good circumstances. At some point, you can generate a data mining solution. As new data is discovered, how is that integrated into existing data? Now, one problem we have is the semester is only 15 weeks long. Normally, if you collect data from scratch, that's very difficult because you have to maybe have a survey, collect the data. Very difficult to do and a lot of pressure. So for this class, we're going to, not collect data from scratch. We'll use some data repository or data found within the data repository, so we don't have to go through the data collection process. That could take months. Cleaning the data is to get rid of erroneous values, duplicate values, missing values, how we're going to address that. And by cleaning data, the goal is to improve the chances of getting better results, doesn't guarantee it, and we'll discuss this further. Pre-processing data involves several different things. You could maybe parse the data. We have, let's say, the date in year, month, date. A data miner might extract out the year, like do string left date 4, or a tokenizer to extract out different parts of it. Maybe if there's commas, and take out piece by piece by tokenizing the commas out. And then we can reduce data by either getting rid of columns or rows or both. And we want to get rid of noisy data if possible there. And it is another option for preprocessing. We might want to merge 2 or more data sets. And that can have problems that, let's say a company merges, they buy out somebody in England, the salary is in pounds there, or let's say a company in Japan, if they use yen and America uses dollars, how to bring those two together. And that'll be discussed preprocessing in a future class. So once we have data cleaned, processed, and the next step is to apply data mining tools and build 1 or more models. Well, what types of data mining tools are available? There are 2 areas there. One is called statistical tools, and the other is machine learning tools. And machine learners can be defined as a sub-area of artificial intelligence focused on the design, development of algorithms and techniques which allow computers to learn either intuitively or by using a deductive process. And the tools might be, well, here's what happens. We categorize the hypothesis. Is it a classification problem? Is it a regression problem? Then we might think about, well, we could use a decision tree. And within decision tree, there's a lot of options there. Or neural networks is like perceptron, backpropagation, self-organizing map, and so forth, genetic algorithm, which I didn't show. So here's some of the general names and some of the specific tools within that area there. So we think about that as we proceed. Now I'm going to stop here and continue on another video in terms of categorizing the hypothesis.